Good morning, everyone. I'm Steve Bowley, the Campus Facility Technical Manager here at CloudPoint. Today's webinar is about converting CAD data to GIS with the ArcGIS Data Interoperability tool. I'll just give a brief overview of the agenda for today. So this is actually part 2 of a data interoperability webinar series. The first one was about a month ago, where I went through what is ArcGIS Data Interoperability, the extension for ArcGIS Pro, and how can it help you. So that was a more sort of general, what does it do? How do you install it? How do you work with it? How do you automate general GIS tasks with that tool? That webinar is up on YouTube. There's also a blog being posted on our website about it. So some of the detail that was in that we won't cover today. So if you want to go back and watch that one, it is up there on the CloudPoint Geospatial YouTube channel. Today's webinar, we're going to focus specifically on converting CAD to GIS using the data interoperability tool and the challenges that presents, and how this tool in particular can help with that, and how you can build some workflows that help automate that process. We're going to take a quick look at CAD data in GIS, so looking at some AutoCAD data in ArcGIS Pro. And then we'll just jump into a demo, and we're going to build an FME workbench using the data interoperability tool within Pro and show you how you kind of build that from scratch. So we'll just move on into the slides. And please stop me at any time, ask any questions. I'm happy to pause, and I'll stick around afterwards as well if anyone wants to have any follow-up questions. So why do we want to convert CAD to GIS? Well, that's a lot of different reasons. A lot of clients that I'm working with on the campus facility side are looking to move their data into an indoor GIS system, trying to centralize all their CAD plans into a geodatabase so that you have one source for all of your CAD plans across the entire campus, rather than individual DWGs or individual CAD files per building level. You can centralize everything in a GIS. And then with that, you can expose that data to all the spatial analysis capability of Esri software, and querying and filtering and summarizing, doing statistics on your floor space, for example. You can integrate it with your existing GIS data. So you want to bring your CAD into a GIS environment, so you can overlay it with existing utilities or the external data, the road network, or terrain data, for example, placing your CAD data in its real world context so you can explore it in a GIS environment. You can use GIS to enrich your CAD data by adding in additional attribution, linking it to external data sources like employee data or space management data. So bringing those additional attributes in to enrich your data with extra information. You can share it with the web publishing tools within Esri, enforce data standards and quality control, so making sure that all your CAD data is classified in the same way, and you can ensure that data standards are being enforced in your CAD data during this process when you convert from CAD to GIS. But at the same time, you want to create an automated process, because you typically want CAD to remain as the source of record for your design data. You don't want it to be a one-time data load to GIS, and then you break the link between CAD and GIS. So it's very important to have an automated process that's repeatable. So as your CAD data changes, you can refresh your GIS database, and that connection back to your CAD drawings is not broken. And yeah, as I mentioned, the main goal of this is building an indoor GIS system which can be used for facility management, space planning, indoor navigation, all of those applications. So as you're probably familiar, there's a lot of differences between CAD and GIS data in terms of how it's structured, the data format, and a lot of these things we need to take into account when we're converting CAD to GIS. The main one will be the coordinate system. CAD data is typically drawn in a design space where it has relative positioning using model units. So 0, 0 is the bottom corner of the drawing, and it's scaled, and it might not be using a real world coordinate system or real world units. Whereas GIS demands a coordinate system. Everything has to be placed in a real world coordinate reference system. Obviously, you can georeference your CAD data, and that's a step that is done typically in ArcGIS Pro, but you can do that in AutoCAD as well. The data we're working with today has already been georeferenced, so that's our start point. I don't want to go into too much more detail here. I'll just leave the slide up, but you can see there's a lot of differences between the data structures. Other big ones are CAD doesn't enforce topology rules, so your data can contain gaps and overlaps and self-intersections, whereas once it's in GIS, you can apply those topology rules and check for things like snapped lines and overlapping polygons and self-intersections and things like that. Annotation is another big one, where text is typically a separate object within CAD, whereas in GIS it's a feature-linked attribute of the polygon or the line. And the list just goes on and on. That CAD content, typically you can have, you'll have extra dimension markers and the border of the CAD drawing and inset frames, title blocks, other marginalia, which is all part of the geometry in the CAD file, whereas in GIS, the data is separate from the marginalia and the layout. So we need a way to filter out the information that we really want in GIS and get rid of that extraneous CAD geometry. I'll just leave that up there for a second. So what is the ArcGIS Data Interoperability? The part 1 webinar went into a lot more detail about this, but just briefly, it's an extension for ArcGIS Pro. It is a visual development environment which allows you to create custom export, transform, and load tools. And it uses Safe Software's FME technology. When you're working within the data interoperability extension, you're basically using FME within ArcGIS Pro. A lot of questions about, well, what's the difference between the full FME and the data interop extension? We went into that in detail in the previous webinar. It's essentially a slimmed down version of FME, but for the purposes of 90% of what you'll be doing with GIS data, you have all the tools that you would want available in the data interoperability extension. It's basically FME software licensed by Esri and purchased through Esri. So FME was originally built for this purpose, for converting CAD to GIS. The founders of FME were given a contract by the Canadian Forestry Office, who were mapping forestry using CAD data, and they needed it converted over to GIS. So the original FME software was built for that project to automate that process of converting those forestry CAD plans over to GIS. So it's grown a lot since there. That was the early 90s, and they've added hundreds and hundreds of different data types, including BIM models and point clouds and other things. But going back to its roots, FME is specifically designed for converting CAD data to GIS. It has a lot of inbuilt tools that we will see, which help with that process. So with that said, I'll jump into the demo part. Hopefully this is the most useful part for you guys. Can everyone see? Bill, can you just confirm you see Pro?
Yep, looks good.
Looking good. Okay, great. Right, so we're in ArcGIS Pro. This is version 3.42, I believe, and I have the data interoperability extension installed, and I know that because I have this data interop up here on the analysis toolbar. The way we're going to work with it today is we're going to right-click on a toolbox and create a new spatial ETL tool. That will open a dialog here, so I'm going to give it a name. And if I OK that, it's going to open a new empty FME workbench. So you won't see any FME branding when you open this. It is the data interoperability extension. But once it's opened, you will basically see the same interface that you'd be familiar with if you're using the full FME. The first thing we're going to do is create a reader to read our CAD data. I have some data sets, sample data sets prepared. So I'm going to read this DWG file, which is from one of our clients' buildings. And it's detected from the file extension that it's a DXF, a DWG, sorry. I'm going to bring it in as a single merged feature type. Okay, that. So what it's done, it's read in the DWG file, but it hasn't cached the data into the FME workbench yet. So I'm just going to go ahead and do that by clicking this green arrow here. And I'm going to select the feature types to read. Because I haven't explored this data yet, I'm just going to select all. So we bring in every feature type from the CAD file and run that. We might be going quite fast here. It will be recorded, so if you need to watch it back, we can do that. But just in the interest of time, I'll be going through here. So what this is doing is reading in the CAD data, and you can see it's read in 112,000 CAD objects. One thing I'm going to do here is add in some additional CAD attributes that I want to bring in. Because if we look here in the feature inspector, we've got a number of unexposed attributes. And this is one of the advantages of FME, that it exposes more attributes than you would typically see when you load the data directly into ArcGIS. So you can choose to expose these additional attributes. So I'm going to expose the entity handle, the AutoCAD layer, base name. Let's get the data set. So that. While that's running, I'm going to start to add a few more transformers into my workbench. So I know that this data doesn't have a projection. So the projection system is not defined. So I'm going to add in this transformer called coordinate system setter. And I know that this is state plane Indiana East, which is the 1301 WKID projection system. So I'm going to define it as that. The next transformer I'm going to add is called 2D Forcer. So what that does is if we have any 3D objects in our CAD data, I want to force them to be 2D because we're trying to get a 2D floor plan out of this data. So it will flatten everything to 2D. Now that's finished running, it's cached the data in. I can see that it's got these additional attributes that I added in. So we're reading in the AutoCAD layer, the FME base name, which is the file name, and then the path. You do have a visual inspector here, so you can see a visual preview of your data. Let that load. So it's not aligned with the base map yet because we haven't run the coordinate system projection. So we'll just run that. Okay, so that's run through, and we can see a visual preview, and we see it's georeferenced correctly, and we can inspect the data. I would normally have this visual preview on another screen, but obviously for the webinar, it has to be within here, but it's a nice way to have your visual preview on a second monitor. Next thing we're going to add is called a geometry filter. And what that's going to do, I just want to filter out the text, the lines, and the areas. I'm not interested in any of this other data. I don't think the CAD data even includes any of that. So run it through that. Then I'm
Hey,
going to
Steve,
add
I think we got a quick question that is pertinent right now. Curious, someone wanted to know, how does this workflow differ from using a CAD to geodatabase geoprocessing tool in Pro?
Right. Yeah, that's a great question. So what we're doing here gives us a lot more control over what we want to bring through from the CAD and what we want to leave behind. And it allows us, as we bring the data through, to rename things and filter things out of our CAD data, whereas the out-of-the-box CAD to GIS tool within ArcGIS Pro will literally convert your point line and polygon to a GIS format, but doesn't give you any control over how you filter it. So as we go through, yes, you could obviously use that tool, but you've then still got to do a lot of manual filtering within GIS, selecting by attributes, selecting by layer, and exporting out each individual one. Whereas as we go through here, you'll see that we can break this down even further and really be sort of precise about what lines and polygons we want to bring through from the CAD, and then save it as a repeatable workflow so that you can run the rest of the levels of this building and then all the other buildings on campus through the same tool, rather than having to do it manually in GIS each time. So that's kind of the main difference here. The next thing I'm going to add is area calculator. And I'm just going to call that attribute. Call it gross area. I'm going to add an attribute rounder to that to round the attribute that we just made to 2 decimal places. Then the next thing we're going to do is add an attribute filter. And this is where it starts to get really useful. This attribute filter is one of the main transformers that you really want to use in here. So What that does is we can split things up by the AutoCAD layer and load in all the different CAD layers that we have, import those. And we can run this, and it's going to filter our area polygons by the various CAD layers. So you can see here we've got sanitary fixtures. This sana fixed is in the same, in CAD, it stores those polygons in the same layer as the walls and some of these gross area polygons. So we want to separate these out because we don't want all of that coming through into the same GIS feature class. So if we look at this one, FF gross, just as we kind of explore the CAD data, that is just a single polygon for the entire building level. If we look at FF data, that is the individual rooms. And then we have another one called FF non, which is the some of the interior spaces as well. These are they're not rooms, they're sort of connecting spaces. So obviously your CAD data is going to be very different to this. It depends what layer naming convention you have. It will have to be customized, based on your particular data. But as long as it's standardized and you have things separated out into layers, then you can extract these. So what we're going to do is now create a writer. We're going to write that data to a file geodatabase. So we're going to create this and say building geodatabase. And then okay that. And we're going to create a polygon feature class within that geodatabase. We're going to set it to drop and create when you're creating a table so that it will overwrite the table each time that we make changes to our tool. We have a feature class here. We're going to call this building level. And I'm just going to give it that FF gross feature. So that's that one building level going in there. And we're going to create another feature class and call that building spaces. And we're going to connect up the FF data layer and the FF non into that. And if we run this entire workbench, what that's done is it's written these building spaces out to the feature class layer there. So we can check that back in Pro. Let's get back to this. So one thing we need to do here before we write the data out is I'm going to put in an Esri reprojector. What that's going to do is reproject the data before we write out to GIS database. So I'm going to select this.
And just to remind everyone, we're obviously getting closer and up to 11:30 our scheduled time, but we do record these. And anybody registered, you will get a link sent to you. You can find that on YouTube as well. So, but if you have more time, stick around and Steve will finish this up here.
Thanks, Bill. So I have a finished workbench, which I'll show in a minute, but this kind of shows us the process of how, at least for the areas that we've separated them out, and we're writing, gone through them through some processes, done some reprojection, created an area attribute, and we're writing out to a geodatabase. I'll just let that run through. The nice thing is you can inspect it at every step of the way. So these little green icons here on each step, you can see what your output, what your data looks like at that step of the process as it's going through. This reprojecting is taking a while. While that's running, I wanted to show you that in Pro, the way we run these is that FME workbench, once you've saved it, you set up the input as a user parameter. So you can just run it like you would a Python script or any other tool, a geoprocessing tool. So you don't need to open the FME workbench to run it. Once it's saved, you run it back as a geoprocessing tool here. Still running. So just as an example of where you would take this in the end, this is a full workbench where we've got a number of GIS outputs on the right-hand side, and some of the things I've done in this one are to split out the text attributes. Let's see the best way to show this. So we're filtering out the annotation, these text objects, which is the room numbers. Let me show you that here, this text string, and then passing that through a point on area overlayer and passing the spaces that we processed in the earlier workbench into this point on area overlayer tool. What that does is it merges the attributes. So now we have, rather than a separate piece of annotation text, we actually have the room number as a attribute of the polygon. So you can create GIS attributes by merging the CAD annotation with the polygon. And what that's done is create a room number attribute in the output GIS. You can do the same with building number and building level. Those are being extracted from the CAD file name itself. We look at some data that I processed earlier. This is the output from that workbench that we were just looking at. Now it's created these 3 GIS layers, and we can see that we've got the room numbers as annotation within GIS, and those attributes have been put into the GIS layer as an attribute called room number. So that's coming through from the CAD annotation. So that sort of thing is something you wouldn't be able to do with the out-of-the-box CAD to GIS conversion tool in ArcGIS Pro. So it gives you that flexibility and control of what you're bringing through from the CAD. That one's still reprojecting there, so it's a rather large file, this one. But yeah, it's about what I wanted to run through. There's a lot of other things you can do with this, obviously, but hopefully that gives you a taste of kind of how you would do it in FME. There's some other nice things that you can do where all of these transformers up here are to do with the polylines, so you can put them into a group, a bookmark, and then say all of that is the unit processing You can bookmark those, and then you can move all of those around in one block to kind of tidy up your interface like that, and then just set up your user parameters over here. This is where you set up your inputs, and then you can share this workbench with someone else, and they can just run it from Pro.
Couple more questions for you, Steve.
Yeah.
We had one, I think there towards the end when you were demoing. Can you only rerun it on CAD sets that have matching data or layer names?
Yeah, that's a good question. So ideally, your CAD data would be standardized at least within the same building, so you can expect the same layer names. To account for variations in the layer names, what you can do is set up a spreadsheet which has all the different variations you have in your CAD data. So you could have a door called A-door, or they might, in another layer they might be called doors. In another layer they might not be classified at all. You can set that up in a spreadsheet, which kind of is an index, and say, okay, if I find any CAD layer called this, put it into this GIS layer. That would be done through a database joiner tool, which would be this one. So it kind of, you join your data to an index spreadsheet. That's how I've managed that. But yeah, that's a typical problem that, you know, between different buildings, you've got a different CAD data standard. So you would need to add in additional layer names into your attribute filter to account for that.
Excellent. Another one. What is your opinion on ArcGIS for AutoCAD plugin versus AutoCAD Map 3D ArcGIS interoperability?
Yeah. I have used the AutoCAD plugin. It does has a lot of QA tools for QAing your data before you take it over to GIS. So it does a lot of checking for making sure lines are snapped and polygons are closed and things like that. I'm personally not too comfortable in the AutoCAD environment. I like working in GIS and with FME, so that's my sort of comfort zone. I think it's whatever works for your workflows. If you're comfortable in AutoCAD, I know that's a very good tool as well for preparing your CAD data for conversion to GIS. There are obviously lots of other ways of doing this. You could have done this in Python, or you could do something in Model Builder in Pro. If you're comfortable with Python, you could automate all of this that way. I think what FME does is gives you a nice visual interface and a lot of control over the process, and it's easily communicated with someone else as to what's going on at each step of the process. Is what I like about this one. But yeah, I'm not too familiar with that tool, although I know a lot of people use it for preparing their CAD data.
Excellent. I think you might have been getting to this, Steve. Sorry. Someone was asking, can you show the other transformers that you had flashed by a second ago?
Sure. Yes.
I'll let you carry on. Go ahead, Chip.
This was actually my last slide in the presentation. There was a lot more I wanted to get to today. Maybe we can do a follow-up, but these are the transformers that I would recommend looking into. The geometry validator is one that I have in there that will check for overlapping polygons and self-intersections and lines that aren't snapped or invalid geometry. And what you can do is actually report that as an error in a QC table in your geodatabase. So as it runs through, it can separate out any pieces of geometry that don't pass that validation. You can see there's a failed option here. You direct the failed objects to a table, and then you can email that table to someone. You can set it up with a Python script that you get a report. That's a useful one. Database joiner, very useful to enrich your CAD data with external spreadsheets or database tables that you might have, like space categories and things like that. You can join that to your CAD data on the way through. You can join to ArcGIS Online services if you want to bring in data from there. Yeah, these are all useful.